Don't worry about your notes. Just, I didn't like the problems I had written down. We're not going to use it. Okay, so we're going to do 3 problems. I'll give you your assignment. Again, you have a full work day tomorrow. You also have, I'll give you the study guide before I leave today. I think that you'll do very well on this test. Again, the test is Friday. It'll be a little bit shorter test than normal. And so our objective is we want to identify all the intervals of increasing, decreasing, concave up, concave down, maximums, minimums, and points of inflection. So those are all the things we need to do. Okay. So here's just how I organize my work, and you can choose to do it however you want. Okay. I first take the first derivative. What's the first derivative? Okay. And I set that equal to 0. And you can factor out x squared minus 1. Does that factor? X plus 1, x minus 1. So what are your solutions? -1, +1. I also take the second derivative. If this is my first derivative, what is my second derivative? So that equals 0, and x is 0. Very good. So this is the point where I like to draw my graph, because we're going to do a rough sketch. And I just put the second derivative on the bottom. I put the first derivative on the top, -3x squared plus 3. And I just mark my points. I know that 0 is an important point for the second derivative, and I know that -1 and +1 are important points for the first derivative. And I like to line everything up so it's nice and in order. So -1 matches on this number line just as it does here. And so everything I have up on this number line should match with what I have graphically here. Okay? So I found my really important points. In fact, those are called my critical points. It's where something interesting happens. So now we're going to see exactly what happens. So, how do I tell if something is increasing? First derivative is positive. Decreasing? First derivative is negative. So let's look at that first. All we do is our interval testing. What point could you plug in right here? That gives you 3. So that's positive. So I'm increasing. Not necessarily. I'm going to show you an example where that's not the case. I could plug in -2. -2 squared is times -3 is -12 plus 3 negative. And if we were to plug in, say, a +2, again, we would get -12 plus 3 is -9, negative. So I can start to answer this. What is my interval for increasing? -1 to 1, intervals of decreasing. Is there going to be a relationship between these two? There is. You can see that -1 to 1 fits right in between there, doesn't it? Okay, that should always be the case. You should always be able to put all real numbers, hopefully, as long as the domain is all real numbers, between those values. Concavity. What do I use to determine concavity? The second derivative. Very good. -6x. So let's plug in a negative value, -1. What do you get? 6. So it's positive. So it is concave up. And now if we plug in a positive number, you get a negative result. So it's concave down. So it's concave up from, it's concave down to infinity. Okay, this is the really important point that sometimes people forget about. -1 and +1. Those are the points where I might have local max and mins. If I am concave up, so it's shaped like that, am I going to have a max or a min there? Min. So we know that at right here is the point -1, and here is going to be +1. The inflection point, you know, is at 0. All we need now is the y values. Okay? How do I find the y values? Into the original. 1, make it negative. -1 plus 3 is 2. Minus 2 is 0. Plug in -1, you get +1. Minus 3 is -2. Minus 2 is -4. Plug in 0 and you get -2. Do we have enough information to draw a rough sketch of the graph? You sure do. And it's going to match it with exactly what we have here, okay? So I can plot my maximum. I'm going to just put some coordinates here. 1, 2, 3, 4. 1, 2, 3, 4. Looks like I have an inflection at 0, -2. Looks like I have a maximum at 1, 0. Looks like I have a minimum at -1, -4. And you know that the function is decreasing before that. It's negative, so it's decreasing. You know it's concave up, so it starts to turn up. So you know that you have that kind of shape. You don't like my graph. You're making fun of my graph. Sarah's making fun of my graph. Sarah, I'm now going to make you stand up and show everybody your graph. Oh, okay, all right. Can you guys see that? Look how I divide up the first derivative graph. See that my graph is definitely decreasing here? This is a way for me to check all my work. It's positive in between here. You can see how it's going up. It's negative here. It's going down. This part down here, the x-axis divides it down the middle. You can see that this portion of the graph that I draw in green is going to be concave up. And the other portion that's in blue, that's the portion that's concave down. And so it all matches. And it's all there. What do you think? Inflection? The inflection point comes from setting the second derivative, which was -6x, equal to 0. Okay, let's try one that Larry talks about. Larry talked about one where, what if you don't have, does it always switch? Well, here's an example for you. Okay, f of x is equal to x to the 4th plus x to the 3rd minus 1. Set it up the same way. Increasing, decreasing, concave up, concave down, max, min, inflection. I start by finding the critical points. There is nowhere where the function is undefined. I take the derivative and set it equal to 0. What is the derivative? Very good. Got that? Take the second derivative. Just to save space, I just don't even write f double prime anymore. What do we have? Factor of 6x. So you've got 0 and... Okay. We found our critical points. You ready to go to work? I'm going to put my first derivative up there, which is 4x to the third plus 3x squared. Put my second derivative down here, which is 12x squared plus 6x. We have some interesting points at 0, -1/2, and -3/4. So again, this is why I like to do this, because this way I can make the graph kind of fit my window the way that I want. So I'm going to call that -1. Call that +1. It's got 1/2 right in between there. So each mark is a fourth. That way it can get a really good idea of what that graph is going to look like. So my first derivative, I have 0, and I have -3/4. So I have 0, I have -3/4. My second derivative, I have 0, and I have -1/2. What do you do now? Yep, do our positive negative thing. What's the number to the left of here that we can plug in? -1 to the third is -1 times 4 is -4 plus 3 is negative. What's the number here you'd like to plug in? -1/2. -1/2 to the third is -1/8 times 4 -1/2. Okay, what's -1/2 squared? 1/4 times 3, 3/4. It's positive. What's the number to the right of 0 that you can plug in? 1. 4 plus 3, positive. Do you see it did not change? Didn't change. You'll see with the shape, it's really cool. Okay, so you got that. What's the number over here we can plug in? -1, and you will get a positive result. Oh boy, we gotta be good with fractions. What's the number here to plug in? -1/4 squared is -1 or +1/8. What? Oh yeah, 1/16. So you get 12/16 or 3/4. And then if you plug in a negative 1/4 times 6, negative 6/4 or negative 3/2, it's going to be negative. And then if you plug in a positive, you get a positive result. So we've got, can we answer these questions? Increasing. Negative 3/4 to 0. And 0 to infinity. You can't include the 0. Because technically, the function is not increasing or decreasing. It has a slope of 0. Decreasing, negative infinity to concave up. Concave down. Yep. You won't have to 0. And then you also have concave up from 0 to infinity. Oops, sorry. Question. Ask the question. For concave up. Concave up, yep. 2 sections where it's concave up. Okay, here's the really interesting part. Look, the max. As you look at negative 3/4, the function is concave up. So negative 3/4, is that going to be a max or a min? That's going to be a minimum. So you've got a minimum at negative 3/4. And then we also have this spot 0. Is the second derivative positive or negative at 0? It's 0. In order for it to be concave up, it would or concave down, you would have to have a second derivative that was negative. But it's not positive or negative, it's 0. So we only have one value, and that's a minimum at negative 3/4. Okay? Your inflection point happens at what 2 values? Negative 1/2 and at 0. How do we find those y values? Okay, if I plug in negative 0.75, I get negative 1.105. If I plug in negative 0.5, I get negative 1.063. And then if I plug in 0, negative. Yep. Now, these are really close together, aren't they? So we'll exaggerate the graph a little bit to make it kind of work out. Okay. Watch what happens. Minimum happens at negative 3/4, and then negative 1 And I'm going to dip down a little bit further just so we can see it, okay? And then we have inflection points at 0, -1. And we have an inflection point at -1/2. And somewhere in between those two values, we're just going to put it. And it says I'm decreasing here, I'm concave up, so the graph is going to go like this. It's going to come down to there. It's going to change inflection. It's going to start to level off, okay, because it has a slope of 0. And then it starts to increase, and it has concavity that's up after that. So it doesn't finish that full W shape. It's just got that. And if you plug it into your calculator, and we were to graph it, and we change our window to match this, so if we go from a X minimum value of, say, -1, let's go -2 to 2, and if we go a Y value of -2 to 2, as we sketch this graph, okay, so see that behavior right there? I've exaggerated so we can see it, but that's exactly what you get. And so that's the hidden behavior in a graph that we were never able to find before, and we just did. Okay. So, you know what? I was going to do a square root one for you, but I'm not going to put it on the test. We'll save it for the next test instead. How's that? Okay. So let's not even look at the last one. I think if you could do these type of functions, you're fine. How about I give you? If I give you 4 of these, okay, you can do 4, right? 4. Let's just do 4, okay? You guys, the directions are basically identical to what we just did. They say set up the intervals of concavity as well as increasing, decreasing, maximums, minimums, inflections, and also give a rough sketch of the graph. And you saw how you saw how I was able to sketch a graph real quick just to check my answers. So there you go. I will come around. Brooks got the first question. I'm going to hand out your study guide as well, and it has second question. Okay.